Alright, this video is part 5 in our review of polynomials. So let's pick up here with number 14. We're supposed to be able to determine visually whether or not these functions are even, odd, or neither. Alright, real quick, give me a thumbs up or thumbs down. No, even, odd, or neither. If you think this is even, show me an even number of fingers like this. If you think this is odd, show me an odd number of fingers like this. And if you think it's neither, just hold up a fist like this. Okay? Alright, put them down. Alright, for the people in YouTube, most of my class was showing me the fist that meant neither. And they were correct. Okay? This looks similar to what would be even. So can you tell me why it's not even? Just jump in there, Jonathan.
Like where it's at on the.
Where does it need to be?
0. The bottom part should be like on the 2, the -2. Or on the line.
I'm listening for one key word in your sentence. Y-axis. Okay? Even symmetry is y-axis symmetry. So the y-axis has to be right down the middle of this. And it's not. Okay? So it's neither.
How do you know it's not off?
We're making a video right now.
Yeah.
Was that my voice to be on?
Okay.
That's not.
Show me on your hands what you think about this one. Even, odd, or neither on number 5. Even, odd, or neither.
15, you mean?
15, yes. Alright, put them down. Alright, see YouTube, my class is awesome. They were indicating to me, I don't want to see that wire hanging down from your head. Can you take it down? Goodness. Most of my class said neither on this one. Almost everybody, okay? This is neither. This looks very similar to, like it's almost odd. So why is it neither? It's close to being odd, but why is it not odd?
It's waiting for one word, y-axis.
Yeah, you guys are correct. The center of rotation is like over here, okay? It has to be the origin, okay? Odd symmetry is when if you turn the graph upside down, it still looks exactly the same, okay? But the center of rotation, it has to be the origin, okay? So if this were the origin, then this would be odd symmetry, okay? So, but it's neither under the circumstances. Okay. Looking at number 16. Show me on your hands what you think about number 16, you guys. Coop. Strike one.
What was that trick?
We're on number 16. Even, odd, or neither. Even number of fingers or an odd number of fingers.
Okay, guys.
Okay. All right, put them down. The consensus seems to be odd, and that is correct. Okay, this is odd. And let me see if this is one I can do individually. Keep hearing that crinkle again over there. Odd symmetry. It's odd if I... Wait, it's freezing up. Freezing up. If I turn it upside down and it still looks the same, that's how I know it's odd. Okay? It still looks exactly the same upside down, so it's odd symmetry. Yeah. Okay, alright, so one more. Show me on your hands what you think of number 17. Even, odd, or neither. 17, put them up.
I had 2, dude.
Okay. Alright, put them down. Alright, pretty much everyone was showing me an even number of fingers, okay? Because this is in fact even. And again, that's because it has y-axis symmetry. What am I doing? The y-axis splits this mirror image right down the middle, so it's going to be even. All right, any questions about that concept?
No.
All right. Moa, did that make sense? Do you understand that? Okay. All right. All right, number 18. We're supposed to solve the following system of polynomials. Okay? Do you think we should probably use substitution or elimination on this one? Definitely substitution. It's already got a variable by itself. It's got this nice little term ready to be substituted into the other equation. So if I take this and substitute it, okay, then this new equation is going to become, I'll go back, I'm going to recopy it. So if I put x minus 5 right there, then what I have is x minus 5 equals, and then I've got the rest of it, x to the third minus 4x squared. Minus 11x minus 6. Okay, so I've got this so far. Now I've got nothing but x's, so I should be able to solve this. It's all x's now. What do you think I'm going to do now, you guys? All right, so what do you guys think I'm going to do next?
I added
Subtraction x.
Yeah, let's get everything on one side. Probably easiest to move this stuff over to the right because there's only two terms. So yeah. Okay, so yeah, I'm going to subtract x from both sides. And I'm going to add 5 to both sides. Okay, so I'm going to have 0 equals x to the third power minus 4x squared minus 12x minus 1. Yay! So now we have to solve this somehow. And I'm just going to put the 0 over here on the right. So that's the same thing. Makes me feel better. Okay, I'm seeing the 4 terms, so I'm looking at it wondering, can I do grouping or something? Nah, grouping's not going to give me the same factor, so that's not going to work. Then I would put it in my TI-30 XS multiview, see if I find any zeros in the list. Did anybody do that already? Okay. All right, so let's put this in the calculator and see if there are any zeros on the table. So I'm going to look at the table, and I normally I start from -10 because it almost never goes past -10. Look at how big those numbers are. Why is it keeping going? Stop. All right, so I'm scrolling down. I'm looking for zeros on the y side. Look at all those negatives. Negatives up. It went from negative to positive and back to negative again.
Now it's still going.
Now it's still going. Got a mind of its own today. But there were no zeros on the calculator that I could use. So that tells me that I need to use a graph. So in class, I'm going to use a graphing calculator. Like if this is on the test tomorrow, you'll use a graphing calculator. At home, you'd have to use like Wolfram Alpha, or if you have a graphing calculator at home, then that's great. All right, so to do the graphing method, you need to have the function typed in from the left. But you also need to have the function typed in from the right, because on the right-hand side we have 0. We need that as well. Okay, so there. Whoops, wrong calculator. So that's why I have this 0 here for the other side of the function. So I'm going to go ahead and hit graph now. See what I'm dealing with. Okay. So even though it seems to be sort of off camera, I can see the bottom of the loop here. I can see that this is your cubic shape. This is an N shape, okay? I'm seeing my 3 zeros right here. So what I'm going to do is I'm going to use the intersection program. So I do second trace, and you just have to memorize this, okay? So second trace. And option 5 is intersect. And I can just type the number 5. All right, I'm going to hit up arrow because I really want to be on the horizontal line. It's just easier to move around. All right, so here I am coming really close to the first 0 on the left. And I'm just going to hit enter 3 times. Enter, enter, enter. Kabam! So there's my first 0 at negative 1.9. Negative 1.93. I'll use 2 decimals. Okay, so let's write that down. Okay, so x equals negative 1.93. Okay, let's. How about the next one? So once again, I have to hit second trace, choose 5, and I'm going to hit the up or down arrow so I can be on the x-axis. And I'll come close to the middle one and hit enter 3 times. Enter, enter, enter. And there's my next one, negative 0.09. I rounded up. So x equals negative 0.09. Okay, and one more time. Second trace, 5. Up arrow to be on the x-axis. Now I'm going to slide over. Okay, and I'll once again enter 3.
Wait, go over one more.
It's close enough.
Go over one more.
I'm going to go over one more though.
No, go.
No. It should be good. It should be good. Okay, so 6.02. 6.02. That's the last one. Okay, and that's it. We're just supposed to solve the system, and these were the 3 intersection points. That's it. Oh, wait, no, a lie. That's a lie. These are the x values. We need the y values to go with them. All right, those are x values. Okay, so yeah, we're gonna have to look at the table, but yeah, we'll just use the y equals x minus 5 option.
I got a question. Why couldn't we just go right to the graph and there was a y next to that number? Why couldn't we just use that number?
That's a good question. The reason is we are not graphing. What we graphed was some kind of combo of these 2 lines so we could find the intersection. What we graphed was neither one of the original functions. So those y values are not the y values that we're looking for. Okay. In fact, I mean, the y values that were with all these points, they're all 0. Okay? Because they were all on that x-axis, but that's definitely not the right thing. Okay? So 6.02. So these are all x values, but we need the y values that go with them. Okay? So we got to plug them in. Okay, so these are all x values. To find the y values that go with them, we can just use this little equation right here. Y is equal to x minus 5. Okay, so for example, if I do negative 1.93 minus 5, you should be able to do that in your head, can't you?
Of course.
Okay, negative 1.93 minus 5. Won't that be negative 6.93? Okay. Okay, so we don't need a calculator to do that. But hey, if you need it, use it. You know, I won't even know. Okay, and we could do the same thing for the rest. So for this one, it would be negative 0.09 minus 5. Can you tell me what that would be without a calculator?
5.09.
Yeah, that's going to be negative 5.09. And this one would be 6.02 minus 5. That'd be 1.02. So these are the solutions. Okay, the x's and the y's, those intersections. Okay, so not just the x's. All right, any questions on number 18? Okay. Is there no 19?
There is there's 20. There's 20. That is the 19.
This is the 19?
That's the 19.
What?
We just did 20.
Bad class.
It goes 18, 20, 19.
All right, so for number 19, we're supposed to solve the following inequalities and place the answer in interval notation. Okay? This isn't the same problem we just did, is it?
No.
Okay, I saw that x minus 5. So what do you think I'm going to do first?
It is.
All right, I'm going to subtract x from both sides,
You know it.
and I'm going to add 5 to both sides.
You know it. I mean,
The difference is less than 1.
no.
Okay? So this is going to give me x to the third power minus 4x squared
This is the same.
minus 12x minus 1 is less than or equal to 0. Okay? We already found the zeros of this on the previous problem because this is the same. I mean, it's an inequality now, but it's the same as what we just did on problem number 18. Okay, so we already know that the zeros are negative 1.93. You know, these. I'm just going to cut and paste them, literally. Okay? So if you're watching this video and you didn't look at number 18 first, you need to go back and watch video 18 before you do 19.
Because the x's are on 18. Right, Ms. Carter?
Yes, sir.
Do your signature like, what is that?
All right, these are the zeros. So the previous video showed how we found them, so you can go back and watch that if you need to. But we'll just pick up from here and do our graph. Okay, so here comes our number line. I'm going to do this by the graphical method. So I'm going to need to do two graphs, a picture graph and then my solution graph.
For 19?
For number 19. So let's do two graphs right now. Okay, let's see. So I've got negative 1.93. All right, I've got negative 0.09. And then I've got 6.02. Okay. These are the zeros of the function. So this is where the function crosses the x-axis. This is where the function equals 0. Okay? Now let's draw this function. Now looking at this, we know it's cubic. So what kind of a shape are we looking for?
Cubic.
Yeah, we're looking for that n shape, all right? It's positive leading coefficient, so we're looking for the right side up n shape. So we'll go ahead and draw that right side up n shape through these zeros. So it's like this. Okay, so this is the idea of the shape. Okay? Now, looking at the inequality though, we want to know where the function is less than or equal to 0. Where is the function below the x-axis? Okay? So the function is going to be below the x-axis right here. Whoa. The wrong thing. Before I color it in, it's less than or equal to. That means I want to include the zeros. Because right here where I'm putting these pink dots, that's where the function's equal to 0. I want to include those because it says or equal to. But then I want less than. So I'm going to draw in the part that's below. And then this part is below. Okay? So those pink intervals are what I need in my solution set. All right? But for my actual solution, I'm going to only graph x values. I'm going to flatten this out, basically. So let's redo the graph for real this time. All right, but it's going to start off the same. Negative 1.93, negative 0.09, and 6.02. Shall I use open circles or closed circles? Closed circles, because of the or equal to, we're including the endpoints like we said. Okay? Now just look at the pink, because that's where the solutions are. All right? So I see that I have solutions to the left of negative 1.93. So I'm going to draw an arrow to the left to represent those solutions. And I see I have solutions between negative 0.09 to 6.02. So I'll draw the segment between to represent those solutions. Okay? So that is the graph of my solution set right here. Okay? We also need to include the interval notation to go with it. So what do I write for the left arrow?
Negative
Negative infinity to negative 1.93
You guys are.
with a box on it, okay? And then negative 0.09, you got it. 0.02,
6.02.
yeah. And somebody already said it, we need the union symbol when there's more than one part of your answer. Okay, so that would be a complete answer to problem number 19.
Bam.
Wait,
Look, Chad.
Now we're ready to do it.
Well, actually, I'm going to stop this video right now because it's already 20 minutes long. All right, I'm going to do number 20 on the next video.